Today's problem, largest divisible subset, difficulty medium. Given an array of distinct positive integers, your task is to find the largest subset such that for every pair of elements x, y in the subset, either x divides y or y divides x. Okay, we'll look at what that means. Note, if multiple subsets of the same maximum length exist, return the one that is lexicographically greatest after sorting the subset in ascending order. I don't think they really mean lexicographically greatest, at least lexicographically to me means alphabetically, like sorting as strings, which is not what we want to do. But well, we'll look at that a little bit more as well. Let's look at the constraints, then we'll look at an example. Constraints, the array size can be up to 1,000. All right. Array numbers, the numbers in the array can be anywhere between 1 and 1 billion. Expected complexities is n squared because we're going to have to do divisibility comparisons on each pair of numbers. We need a nested loop to do that. Company tags. A lot of big name companies like this problem. Topic tags, dynamic programming, sorting, arrays. Okay. Okay, let's look at an example here. The sorting is useful because if the numbers are in just a random order, it's hard to see the divisibility relationships. If the numbers are sorted, then the divisibility relationships only go in one direction. In this case, looking at this, which is actually the output of this example, but it's easy to do the divisibility relationships because you just have to go one direction. So 16 is divisible by 8, 4, 1, yes. Is 8 divisible by 4 and 1? Yes. Is 4 divisible by 1? Yes. All right. I want to try to get this into a spot here where we can see the interesting parts of the code, but also have space to write in. Okay. I've actually gone through and done this incorrectly, I think, 3 times. The lexicographically greatest really turns out to be the hardest part of it to me. So let's try an example here. Let's imagine, I gotta get a pen. Let's imagine that we have, where is it? Oh, there it is. Let's imagine that we have an array and we've sorted it. And here is the array. 1, 2, 3, and 6. Okay. So there's the sorting. There's the sorting part. The dynamic programming is you have a dynamic programming array. It's the same size as the input array, and at each index, it will give you the largest possible array. Largest possible subset at each index. All right, so the first one is just a 1 element array. If we add in the 2, then the maximum possible subset goes to 2 because 1 and 2 do form a divisible subset. If we go to 3, maximum possible subset is still 2. It could be 1 and 2, that'll work. It could be 1 and 3, that'll also work. And when we get to here, 6, that is going to be a 3. But again, there's 2 possibilities. 1, 2, 6 works. 1, 3, 6 works. My first thought was, well, we can do this just, going forward and keeping track of a parent index or a previous index. So when we find that 1 and 2 work together, we set the previous index, and this will be a separate array, the previous index for 2 to 0, meaning it's linked to the 1. 3 is not going to work with 2 and 1, so we toss it out. We get to 6. Now 6 does work with 2 and 1, so we could set the previous index here to 1, and then we can reconstruct the array. 6 links to 2, 2 links to 1, and that's our subset. The problem is that 1, 3, 6 is also a valid subset, and in fact, it is lexicographically greater than 1, 2, 6. So 1, 2, 6 is the wrong answer. 1, 3, 6 is the right answer. So that's the problem in trying to do it going forward. We could do it going backward. That is, build it up and say, all right, so here's where the maximum subset starts, and then just go backwards and check the divisibility relationship. So 6, is it divisible by 3? Yes. All right, so we'll put that in the subset. We have 3 and 6. 2, that's not going to work with 3, so we toss it. 1 works, so then we have 1, 3, 6. That's the right answer. All right, let me write out a second example here. Whoa. Oh, can I get rid of that? Okay, good. All right, so take a look at this example, 4, 5, 15, 88. We're going to try to do the same thing. The maximum subset size is going to be 2. And we're going to start at the end and go backwards. So we'll start here with the 88. Is it divisible by 15? No. How about 5? No. How about 4? Yes. Okay, so that makes a divisible subset of size 2. Now, here's the problem. This is also a divisible subset of size 2, and because of the lexicographically greater requirement, 515 is lexicographically greater than 488, and so therefore 488 is not the right answer. So now we've got 2 ways to fail here. I mean, we failed going forward where we got 1, 2, 6 instead of 1, 3, 6. We failed going backwards where we got 88, 4 instead of 15, 5. And we are going to try another approach, which is kind of a combination of the first 2 approaches. Here, let's do this. Let's erase this. We're going to sort it, but this time we're going to sort it backwards. Okay? So we'll do 88. 15, 5, and 4. And we're going to reinitialize the DP array. DP array is always initialized, in this case, to 1s, because all we know at this point is that each element represents a 1-element subarray. Let's clean that up. Let's go back to reintroducing the parent array, or the previous index concept. These are going to be initialized to -1, which just means that we are not using them yet, that the corresponding index in the array is not part of the answer. All right, so that actually takes us to here. We need a couple more variables here and here. I'm going to abbreviate those for space purposes. Max count. We'll say max count. Max count, let's set it to 1 because it really can't be any smaller than 1. Max index, we will set to 0. And we need loop variables. So let's set I and j as loop variables. I is initially 1. J is initially 0. I is going to go through the whole array. J is going to go from 0 to I, not inclusive. All right, so let's go through here and see what happens. Array at 0 is 88. Is that divisible by 15? No, it's not. So we'll drop out of the inner loop. Is dp at 1 greater than max count? No, they're both 1. So we don't need to do anything here. All right, increment the outer loop. And we're going to say, is 88 divisible by 5? And it isn't, so we don't do anything here, but we'll increment j. What, is that right? I'm sorry, yeah, is 88 divisible by 15? No. Is 88 divisible by 5? No. So we don't do anything there. Drop out of the inner loop. Is dp at 2 greater than max count? No, they're both 1, so we don't do anything there. And final pass through the outer loop. We'll reset this to 0. Oh, wait. I'm sorry. Let's hold on here. We did not finish the last pass through the inner loop because we didn't increment j to 1. All right, 1, and this is still 2. All right. What just happened there? 2. Okay, so now the question is 15 divisible by 5? And the answer is yes. Is it also the case that the dp array at 1 plus 1, dp array at 1 plus 1, which would be 2, is that greater than dp array at 2? And it is. So that means this becomes 3. We'll set the dpi to dpj plus 1. And that's right, because we now have a 2-element subarray that works, 15 and 5. And we're also going to set the previous index at 2 to 1. So previous index at 2 is now set to 1. So we could just take the negative off. All right. Now we drop out of the loop. We say, is dp at 2 greater than max count? And dp at 2 is 2, and it is greater than max count. So we set max count to 2, which means that we now have a 2-element subarray that works. We have a divisible subarray of size 2. We will also set max index to I. Max index to I2. All right. This is how we're going to miss the 4 here, because we've already set the max index to 2. Now, eventually, this is going to go to 2, but the dp is not going to be greater than max count. So we're not going to set the max index to 3. It's going to stay at 2. That's where we want it. All right, final pass through the outer loop. I goes to 3, j goes back to 0. And we say, is 88 divisible by 4? The answer is yes. Is it also the case that dp at 0, 1 plus 1, 2 is greater than DP at index 3? And it is. So we set the DP at 3 to DP 0 plus 1, and that's correct. We have a new 2-element subarray that works, 88 and 4. And we set previous index for 3 to J, which is 0. All right. So this becomes 0. Increment 1 is array at J. Is 15 divisible by 4? No. Okay, let's increment it. Is 5 divisible by 4? No. All right. So we'll drop down here again. Is DP at 3 greater than max count? It's not. It's the same. So we don't do any of this. All right? Now we start constructing our result. We say while max index is not equal to -1, we will add the result of array at max index. And max index is 2, meaning we are going to add to the array the 5, and that is correct. That is what we want. Max index will then be set to the previous index. So we're tracing it using the previous index array. The previous index at max index, previous index at max index is 1. So max index now becomes 1. Next, max index is not -1. We will add array at 1, and that is 15. Okay. 5 at 15. And max index will be set to the previous index at index 1. Previous index, now that is -1. And that means we are done, and we can return this result, which is correct. All right. Turning off the writing. We're going to run this one more time. Well, I hope it's one more time. Okay. So, I mean, you can see that I've gone through this multiple times and failed, but we do now have the correct answer. This to me is kind of on the high end of medium, because you have to kind of, it's the lexicographically greatest, because it is possible to find a way to do it forward that works sometimes, but not all the time. And it's also possible to find a way to, map the greatest divisible subarray backwards that works sometimes, but not all the time. And I don't know. It's just sorting an array backwards. It's just not the first thing that really comes to mind, but in this case it works. So please like the video, subscribe. You'll get you'll get a notification in your inbox every time I post one of these. Should be every weekday, and we will see you next time.